Imagine being like a highly respected, brilliant scientist in the 1700s.
Right, like the absolute top of your field.
Exactly. And believing with your entire heart that fire was a magical, invisible fluid.
Yeah, and not just any fluid, but I mean a fluid with negative gravity.
A substance that actually made things lighter just by, being inside them.
Yeah,
I mean, it sounds like science fiction today.
it really does. But that wasn't some fringe late-night tavern theory. That was literally the peak of human science for a really considerable chunk of modern history.
It's wild to think about. And it reveals just how desperate we are to categorize the unknown.
Oh, completely.
Yeah.
When you look at the historical landscape of trying to define the fundamental building blocks of reality, you realize it's just the absolute definition of muddy waters.
Sure. I mean, for most of human history, figuring out what the universe is actually made of was this messy collision of, like, philosophy, raw observation, and just deep intuition.
Yeah, people are just doing the best they could with what they had.
So, welcome to this deep dive, everyone. Today, our mission is to explore one of the most enduring, fascinating concepts in all of human history: the classical elements.
Earth, water, air, and fire.
Exactly those four. And we are going to trace their incredible, like, 2,500-year journey.
It's a huge timeline.
It really is. We'll look at how humanity's attempt to understand reality evolved from ancient Babylonian myths and then became the absolute foundation of Greek natural philosophy.
Right, and how it rippled across global cultures like India and China.
Yeah, before being violently dismantled by the scientific revolution and then ultimately finding this super surprising rebirth in modern psychology.
Which is just a fascinating twist at the end. And to map that sweeping timeline, we're synthesizing a massive stack of sources today.
We've got a lot of ground to cover.
We really do. We're pulling from the biographical accounts of early chemists, specifically looking at the meticulous and honestly often dangerous lives of Robert Boyle and Antoine Lavoisier.
Oh, Lavoisier's story is so tragic.
It's heartbreaking, yeah. And we are also integrating historical deep dives into Greek and Eastern philosophies, alongside these modern explorations of psychological and astrological frameworks.
So we're going to be jumping from, ancient temples straight into rudimentary chemistry labs, and I'm just thrilled you are here in the room with us to explore it.
It's going to be quite the ride.
Definitely. But before we get to the laboratories, we really have to look at how humanity operated before the scientific method even existed.
Right, because before formal philosophy, our primary tool for deconstructing the universe was, well, it was mythology.
Mythology, exactly. And when you dig into the earliest creation myths, a pattern emerges pretty much immediately, right?
The elements weren't viewed as inert physical substances at all. They were divine entities with literal agency.
Like they were literal gods shaping the cosmos through conflict.
Precisely. They were the engineers of the universe.
The perfect example of this is the Babylonian creation saga, the Enuma Elish. I mean, it's one of the oldest known stories in human history, dating back to the second millennium BCE.
It's incredibly ancient.
Right. And the universe in this text doesn't begin with a Big Bang. It begins with this cosmic family feud between personifications of the elements.
Yeah, you have Tiamat, who is this terrifying dragon goddess representing the primordial chaotic salt sea.
And Apsu, who represents fresh water.
Right, and the mechanics of that myth are highly specific to the environment of Mesopotamia.
Because they lived right where the fresh river water and the salty Persian Gulf mixed together on a daily basis.
Exactly. It was a daily observable phenomenon for them. So the conflict in the story reaches its climax with the hero god Marduk.
And what's crucial to our timeline is the weapon Marduk actually uses. He doesn't just, swing a sword.
No, he is given control of the four winds, the element of air, to battle Tiamat, the salt water.
He literally traps Tiamat by inflating her with the winds, which is such a crazy visual, and then he physically splits her body in two.
Yeah, and from one half of this watery elemental corpse, he creates the sky, and from the other, he creates the earth, the mountains, and the clouds.
It's brutal but fascinating. And you see a really similar architectural logic in ancient Egypt, right?
Yes, where the sky and the land were believed to have emerged from an infinite dark primordial sea called Nun.
So in both of these cultures, the fundamental substances of creation are water, air, and earth.
But the assembly of those things is entirely attributed to supernatural forces. The gods are doing the heavy lifting.
But the massive transition, the moment humanity starts shifting from theology to early physics, happens when thinkers decide to just stop blaming the gods.
Right, they start looking for natural mechanisms instead of supernatural ones.
And that intellectual pivot occurs in ancient Greece with the pre-Socratic philosophers, starting around, I think, the 6th century BCE in the city of Miletus.
Yeah, and they began this relentless, obsessive search for the arche.
The first principle.
Precisely that, the single primordial substance from which absolutely everything else is derived.
They were trying to find the ultimate common denominator of physical matter.
And what's wild is that they all had totally different conclusions based on looking at the exact same world.
Totally. Like Thales, writing around 626 BC, he looks at the environment and boldly declares, the arche is water.
Which, honestly, if you put yourself in his sandals, is a brilliant deduction.
It really is. I mean, you need water to live.
Yeah.
It falls from the sky. It bubbles out of the ground.
And most importantly, it is the only substance they could observe existing in all three states of matter naturally.
Right. It turns into solid ice and invisible vapor right in front of them.
Thales recognized phase changes long before we even had the vocabulary for it.
But then his successor, Anaximenes, wasn't satisfied with water at all.
No, he argued the primordial substance had to be air.
And he actually proposed a real mechanical process for how air turns into everything else.
Yes, condensation and rarefaction.
Okay, let's unpack this for a second, because Anaximenes is actually describing density here.
He really is, yeah.
Think of it like a massive crowd of people in a room. If the people are running around frantically, spread far apart with lots of energy, that's rarefaction.
Right. And Anaximenes said air thinned out like that becomes fire.
But if you pack those same people shoulder to shoulder so tightly no one can even move an inch, that's condensation.
So if you pack air tightly enough, he argued, it condenses into wind, then clouds, then water, and finally solid earth and stone.
It's a remarkable leap to suggest that qualitative differences, like the difference between a hot flame and a cold rock, are just the result of quantitative differences in how tightly packed a single underlying substance is.
It was revolutionary, but then Heraclitus enters the debate, completely rejecting both water and air.
He's the fire guy, right?
Exactly. He observes that the universe is defined by constant, unstoppable change. You cannot step in the same river twice.
Right, the famous quote.
So therefore, he thought the fundamental element must be the literal embodiment of transformation fire.
But the thinker who really throws a wrench in the gears here is Anaximander.
Oh, Anaximander is fascinating.
He steps back from his peers and essentially says, you guys are all just looking at the physical stuff in front of you, but the arche can't be water or air or fire.
Because, as he pointed out, if one of those was infinite, it would have destroyed the others by now. Fire would have evaporated all the water.
Exactly. So he proposes something totally different, the apeiron.
The boundless, indefinite medium.
To me, Anaximander is basically anticipating modern astrophysics here. He's looking past the stars and saying the fundamental stuff of reality is the dark, imperceptible space between them.
That's a great way to look at it.
It reminds me of the modern concept of the quantum soup, or even dark matter. This idea that the base of reality is something we literally cannot directly perceive, but from which all observable matter kind of bubbles up.
Anaximander's apeiron was incredibly abstract for a society without advanced mathematics.
Yeah, it was super ahead of its time.
But this explosion of competing monistic theories, theories claiming there is only one fundamental substance, it created a philosophical gridlock.
Because how do you prove whether the universe is made of water or fire? You can't.
Right. And that gridlock is finally broken around 450 BC by Empedocles.
Empedocles looks at the debate and essentially says, why does it have to be just one?
He creates a pluralistic model. He declares there are four fundamental roots, or rhizomata, which are fire, earth, air, and water.
And that everything in the universe is just a different mixture of these four ingredients.
But he didn't just philosophize about it. He actually conducted experiments, which brought a crucial element of empirical observation to this whole debate.
Yes. The most famous is his proof that air, despite being visible, is a physical substance with actual mass and volume.
The clepsydra experiment.
It's so beautifully simple. He takes a bronze vessel, a water clock, essentially a bucket with a tiny hole in the bottom, plugs the hole with his thumb, turns it upside down, and pushes it straight down into a body of water.
And he observes that the water doesn't rush in to fill the bowl.
Right. There's a pocket tract at the top. The water is physically blocked by the air.
That moment is a huge milestone. Empedocles proves that the invisible void is not empty.
Air is actually something because it exerts pressure and takes up physical space.
But identifying the four roots wasn't enough for him. Empedocles knew that if you just have four static piles of earth, water, air, and fire, you can't explain a dynamic, moving universe.
Like, how does a seed turn into a tree? Or how does a mountain erode?
Exactly. He needed a mechanism for interaction. So he introduced two cosmic forces that act upon these roots: love, or philia, and strife, or nikos.
Which, to a modern ear, sounds like he's bringing poetry back into a physics debate.
It does sound romantic, right? But what's fascinating here is that while the nomenclature is poetic, the concepts are strictly mechanical.
How so?
While love was the force that attracts, unifies, and binds disparate elements together to form complex objects.
So a piece of wood, for example, is earth and water bound together by love.
Exactly. And strife was the force that repels, separates, and breaks things apart.
Like fire turning that same piece of wood to ash, physically separating the earth and water.
Yes. Strip away the romantic names, and Empedocles is basically outlining an early qualitative precursor to our physical theories of molecular attraction and repulsion.
So we've got the raw materials and we've got the forces pulling them together and tearing them apart. But that forces us to face the next massive intellectual hurdle.
Structure.
Right. If the physical universe is made of earth, water, air, and fire, what makes them different on a structural level? What gives fire its heat and earth its solidness?
To find that structural blueprint, we have to move from the attractive forces of Empedocles to the geometric theories of Plato, and then the thermodynamic framework of Aristotle.
Okay, let's dive into Plato. In his dialogue, the Timaeus, Plato actually coins a term that changes the scientific lexicon forever: Stoichein.
Which we translate today as element.
Yeah, but the original Greek meaning is incredibly revealing.
It really is. Stoichein originally referred to a letter of the alphabet, or the smallest syllable in a word.
Plato is using a linguistic metaphor for reality.
Exactly. Just as a finite set of letters can be combined and recombined to write an infinite number of books, a finite set of elements can combine to build the infinite diversity of the physical world.
It's such an elegant way to think about it. And Plato takes the four roots of Empedocles and attempts to merge them with alloatomic theory.
He argues these elements aren't just invisible smears of matter, they are actually made of microscopic, rigid, geometric corpuscles.
He maps the elements to the regular three-dimensional polyhedra, shapes we now literally call the Platonic solids.
And his assignments were highly deliberate, based on how the elements interact with our human senses.
He assigned Earth to the cube, which makes total sense. The cube is the only regular solid that stacks perfectly without gaps.
It is stable, immobile, and flat-bottomed. It perfectly represents terrestrial matter.
Then fire goes to the tetrahedron, the four-sided pyramid. It has the fewest faces, making it the smallest, and its corners are the absolute sharpest.
Plato reasoned that if you touch fire, it feels like microscopic needles cutting into your skin because geometrically, it literally is.
Water is assigned to the icosahedron, a shape with 20 equilateral triangles.
It's the most complex and nearly spherical, which explains why water flows, rolls, and slips through your fingers so easily.
And finally, air is the octahedron, an eight-sided shape, sitting right between fire and water in terms of both size and mobility.
Plato was completely convinced the universe was constructed by a divine craftsman, a demiurge, who used mathematics as the ultimate blueprint.
He was trying to map mathematical perfection onto chaotic, physical reality. And honestly, I can't help but picture a set of Dungeons & Dragons dice when I hear this.
That's a really good visual, actually.
Right, you've got your D4, that little four-sided pyramid that genuinely hurts when you step on it barefoot. That's fire.
Painfully accurate.
You've got your standard six-sided die, the D6, solid and stackable, that's earth. Your D8 is air. And your big D20, the 20-sided die that rolls forever and constantly falls off the table, that's water.
Plato basically envisioned reality as a tabletop role-playing game governed by sacred geometry.
But the dice analogy highlights Plato's primary problem, right?
Yes. There are mathematically 5 Platonic solids. The fifth is the dodecahedron, constructed of 12 regular pentagons. But Plato only had 4 elements.
So he just throws his hands up and assigns the dodecahedron to the shape of the entire cosmos, the heavens. It feels like a mathematical leftover.
It was a bit clumsy, and Aristotle, who was Plato's greatest student, hated this.
He completely discards the static geometric dice.
Yes, and he builds what is essentially a thermodynamic matrix instead.
Because Aristotle argued that Plato's rigid shapes couldn't explain how elements transform into one another. Like, how does a D20 turn into a D8?
Exactly. Instead, Aristotle proposed that the four elements were not ultimate, indivisible objects. They were manifestations of a primordial, unformed matter materia prima.
Combined with pairs of fundamental sensible qualities.
Specifically, the active qualities of hot and cold, paired with the passive qualities of dry and wet.
So he builds this grid. Fire is the combination of hot and dry.
Air, which by the way the Greeks didn't think of as the oxygen we breathe, but rather as a warm, heavy vapor, is hot and wet.
Water is cold and wet. And earth is cold and dry.
This matrix is just a masterstroke of ancient logic because it provides a clear, understandable mechanism for elemental transmutation.
Because if you take water, which is cold and wet, and you apply a heat source to it, you are violently replacing the cold quality with the hot quality.
And the result is hot and wet matter, which is air or steam.
It totally validates their daily experience. You boil a pot of water, the water disappears and vaporizes.
The matrix explains the mechanics of cooking, of smelting bronze, of whether it just worked.
Aristotle also categorized how these elements naturally move. He believed the universe was a giant sphere with the earth at the dead center.
Earth and water, he said, are inherently heavy elements. Their natural gravitational tendency is to move downward toward the center.
While air and fire are inherently light, so their natural motion is to move upward toward the periphery.
This creates a beautifully layered model of the sublunary world. You know, the world beneath the moon.
You have the solid sphere of Earth at the core, covered by a sphere of water, surrounded by a sphere of air, and finally an invisible outer shell of fire.
But hold on, if you look up at the night sky, you see stars and planets that don't seem to follow these rules at all.
Right. They don't fall down like rocks, and they don't drift up and vanish like smoke. They move in perfect eternal circles.
If everything is made of the four elements, why do the heavens act so completely differently?
This is where Aristotle supposedly introduces the famous fifth element, aether, a weightless, incorruptible substance that makes up the stars.
I'm really glad you brought this up, because this is a critical moment to correct a massive historical misconception.
Oh.
Yeah, we have been taught for centuries that Aristotle tacked on aether as a literal fifth element mixed in with the other four, but the textual evidence suggests otherwise.
Wait, really? Because I've always read that aether was his cosmic fudge factor. Like, the moment his neat four-element box couldn't explain planetary orbits, he just invented a magical fifth substance to make the math work.
It is much more profound than a fudge factor. Modern classical scholarship, particularly Werner Jaeger's deep linguistic analysis of Cicero's translation of Aristotle's lost early works, like the Dialogue on Philosophy, reveals a very different Aristotle.
Okay, I'm listening.
Aristotle never treated aether as a physical substance that interacts with our sublunary world. You couldn't, trap aether in a jar.
So what was it?
Furthermore, he didn't even view the four earthly elements as pure, literal substances either.
Wait, what?
To Aristotle, earth, water, air, and fire were categories of material qualities. They were analytical tools. He didn't look at a wooden table and think it was constructed of tiny, pure nuggets of fire and earth.
He thought the table possessed the qualities of coldness and dryness.
Exactly.
That is a staggering distinction. He wasn't giving us a literal recipe book. He was giving us a system of categorization.
Precisely. It was the later Roman scholars, the medieval scholastic monks, and the alchemists who misinterpreted Aristotle. They reified his abstract qualities into literal, physical ingredients.
Aristotle classified properties. The medieval world turned them into building blocks.
And that misunderstanding changes the entire trajectory of human science.
Because once people believe the physical universe is literally built out of these four elemental substances, it naturally follows that humans, as physical objects living in that universe, must be governed by them too.
Physics bridges the gap into biology, medicine, and human destiny.
We see this integration most intimately in the medical framework of humorism.
Yes. The Greek physician Hippocrates and later the Roman giant Galen mapped Aristotle's elemental schema directly onto human physiology.
They proposed that human health, temperament, and even personality were governed by the delicate balance of four vital bodily fluids or humors.
And they line up flawlessly with the thermodynamic matrix, yellow bile maps to fire, hot, and dry.
If a patient had an excess of yellow bile, they exhibited a choleric temperament. They were ambitious, aggressive, easily angered.
Black bile maps to earth, cold and dry. An excess of black bile makes you melancholic, deeply introspective, or even depressed.
Blood corresponds to air, hot and moist. A dominance of blood produces a sanguine disposition. These are your optimistic, highly social, energetic people.
And finally, phlegm maps to water, cold, and moist. This results in a phlegmatic nature, someone who is calm, passive, perhaps a bit sluggish, but highly adaptable.
Put yourself in the shoes of a patient in the 14th century. You go to a humoral doctor with a terrible fever. Today, we know a fever is your immune system fighting an infection.
But to that doctor, you are quite literally too hot and too wet. Your air element is out of control.
So the treatment is entirely focused on restoring homeostasis.
They would prescribe dietary changes, eating cold and dry foods to counteract the heat, or, more aggressively, they would physically remove the excess humor.
They'd pull out the leeches or the cupping glasses to bleed you, literally trying to drain the air element out of your veins.
To a modern listener, that sounds like a medical horror movie.
It totally does. I have to ask, was humorism just an incredibly misguided, primitive guessing game about hormones?
It's very easy to look back with modern medical superiority and dismiss it as butchery. But we must recognize that humorism was a highly sophisticated, internally consistent, and logical system based on the technology they actually had.
Right, they couldn't exactly order a blood panel.
They didn't have microscopes to see pathogens or endocrinological assays to measure cortisol. They used the elemental framework to explain observable, undeniable physiological states.
A humoral doctor assessing a patient for an imbalance was making a genuine, reasoned attempt at therapeutic intervention. They were treating the whole system, aiming for equilibrium.
And here's where the elemental map expands even further. It didn't just apply to the fluids inside your body, it applied to the stars governing your life.
Oh man, the entire foundation of Western astrology is built on this exact same matrix.
Yes, the 12 signs of the zodiac are divided into 4 distinct groups of 3, known as triplicities. And each triplicity is governed by one of the classical elements.
You have the fire signs Aries, Leo, and Sagittarius. Astrologically, these signs embody the nature of fire. They are about pure initiative, burning passion, and transformative, sometimes destructive energy.
The earth signs, Taurus, Virgo, Capricorn, represent terrestrial qualities. Immense stability, rigid structure, and grounded practicality.
The air signs Gemini, Libra, Aquarius govern the unseen forces, intellect, communication, and sociability.
And the water signs Cancer, Scorpio, Pisces rule over the fluid, hidden depths, emotion, intuition, and the subconscious.
An astrologer reading a natal chart isn't just looking at star positions, they are performing a complex elemental calculus.
They look at planetary rulers, which shift in influence depending on whether a person was born during the day or the night, the diurnal versus nocturnal sex.
If an astrologer tells you that you have an excess of fire or a deficiency of earth in your chart, they are essentially doing early psychological profiling.
It's the exact same goal as the humoral doctor, identifying imbalances in your nature to help you navigate life.
It's all about trying to find a predictable map for chaotic human behavior. And what blows my mind is that we still hold this map in our hands today, literally hiding in plain sight.
You're talking about playing cards, aren't you?
Think about a standard deck of cards. The 4 suits are a direct lineage.
They really are.
Next time you play poker, look at the cards. Spades evolved from the Italian suit of swords, representing the piercing, cutting intellect of the air element.
Clubs derived from wands or staves, representing the sparking creative energy of fire.
Hearts were originally cups or chalices, the receptive vessel of the water element.
And diamonds were pentacles or coins, representing the material wealth and stability of Earth.
The structural DNA of the classical elements is perfectly woven into our games.
That symbolic lineage proved incredibly resilient. But the group that pushed the elemental symbolism to its absolute obsessive limit were the alchemists.
Oh, the alchemists. The bridge between medieval mysticism and modern chemistry. A lot of secretive manuscripts, cryptic symbols, and unfortunately, a lot of tasting toxic heavy metals.
During the medieval Islamic Golden Age and later the European Renaissance, alchemy took the 4 Aristotelian elements and began layering on increasingly complex theories of matter.
We see this with the anonymous authors writing under the pseudonym Pseudo-Apollonius of Tyana, who introduced the sulfur-mercury theory of metals.
This was their attempt to explain why metals behave so differently from rocks or wood.
They argued that all metals deep within the earth were composed of 2 opposing principles, right?
Yes. Sulfur, which provided the combustibility and the color, essentially an abstraction of the fire element.
And mercury, which provided the density, the shine, and the metallic fluidity, an abstraction of the water element.
And then in the 16th century, Paracelsus, who was a brilliant, highly controversial Swiss physician and alchemist, steps in and expands this.
He introduces the tria prima, the three principles.
He keeps sulfur for combustibility and mercury for fluidity, but he adds salt.
Salt represented fixity, solidity, and the incombustible ash left behind after burning, aligning perfectly with the earth element.
Paracelsus was determined to unite the chemical and the spiritual. He's also responsible for formalizing the concept of elementals in Western occultism.
He wrote that each of the four classical elements was inhabited and governed by specific, invisible, spiritual beings.
Salamanders lived within and controlled fire. Gnomes moved effortlessly through solid earth,
Sylphs rode the air currents, and undines inhabited the water.
which, as you might note, became the foundational bestiary for almost all modern fantasy literature and role-playing games.
Totally. But while the West was spending 2,000 years building this incredibly rigid, heavily geometric framework based on Greek philosophy and alchemy, Eastern cultures were independently developing their own elemental systems.
And what is so fascinating is that their systems were driven by fundamentally different philosophical worldviews.
Let's travel east. When we examine the Vedic traditions and the medical framework of Ayurveda in ancient India, we encounter the Panchamahabhuta, the five great elements.
The roster looks somewhat familiar, but with a twist. You have Akasha, which translates to space or ether.
Vayu, which is air, Agni, fire, Jala, water, and Prithvi, earth.
While the ingredients resemble the Greek system, the philosophical architecture is distinct. I should clarify a technical term here. The Vedic system is a substance ontology.
Let me stop you there. For someone who hasn't taken a graduate philosophy seminar, what exactly does ontology mean in this context?
Ontology is simply the study of being, how a system defines what things are fundamentally made of and how they exist.
So a substance ontology means the system views reality as being built out of distinct, static things or materials.
Correct. However, the Vedic substance ontology represents a vertical descent of consciousness into increasingly dense matter.
So it's not a flat grid like Aristotle's.
No, it's a hierarchy of manifestation. Space, or akasha, is the most subtle vibration-based element. From the friction within space emerges air.
The movement of air generates friction, which creates fire.
The condensation of fire produces water, and the ultimate coagulation of water forms the densest element, earth.
It is a cosmological sequence of density, and just like the Greeks had the humors, Ayurveda maps these elements to human health through the three doshas.
Vata is a combination of air and ether, governing movement in the body. Pitta is fire and water, governing digestion and metabolism.
Kapha is earth and water, governing physical structure and lubrication. But the system that really shatters the Western paradigm is the Chinese framework, traditional Chinese medicine, and the concept of the wuxing.
The wuxing is usually translated as the five elements, but a much more accurate translation is the five phases, or five movements.
The categories are wood, fire, earth, metal, and water. Right away, notice what's missing. There is no air.
And they've elevated wood and metal to fundamental status. But the ingredients aren't the biggest difference, it's how they function.
The Western and Vedic systems treat elements like static building blocks. I like to think of them as a box of Lego bricks. In the West, a physical object is just a bunch of elemental Legos snapped together.
If you take the Legos apart, they are still just static bricks.
But the wuxing is a process ontology.
Exactly. To use your term, let me unpack process ontology. Instead of defining reality by the stuff it is made of, a process ontology defines reality by how things change.
In the wuxing, wood and fire aren't static substances sitting on a table. They are dynamic phases of transformation. They define how energy moves, peaks, and declines over time.
It is less like a box of Legos and more like an endless cosmic game of rock, paper, scissors.
I love that analogy. Nothing in the wuxing exists in isolation. Everything is defined entirely by how it interacts with the phase before it and the phase after it.
That captures the mechanics of the system perfectly. The wuxing operates on two primary simultaneous interactive cycles. The first is the generating cycle, known as sheng.
It's a continuous loop of creation and support. Wood fuels fire.
Fire burns down and produces ash, which becomes earth. Deep within the earth, metal ores are forged.
Metal surfaces collect water through condensation, and water nourishes the roots of wood to grow.
It's a beautiful cycle. But if the universe only generated, it would be a runaway train. The fire would consume everything.
So you need brakes.
And those breaks are the controlling cycle, or key. Water extinguishes fire. Fire melts metal.
Metal axes chop wood. Wood roots part and stabilize the earth, and earth dams up and absorbs water.
What I love about this is how deeply ecological it is. The Wu Qing mirrors the concept of homeostasis far better than the Western static model ever did.
By having a built-in restraining cycle, it mathematically prevents any single phase from dominating the system.
If fire gets too strong, it melts metal, but it also creates more earth, which absorbs water, which reduces the water available to nourish wood, which ultimately starves the fire.
It is literally a self-correcting algorithm.
It is a profound model of systemic balance, and this algorithm was applied to absolutely everything in classical Chinese thought.
From the organs of the body, to musical scales, to military strategy, and of course timekeeping.
The traditional Ganzi 60-year zodiac calendar brilliantly integrates the 12 animal signs with the 5 phases.
You don't just experience the year of the rat. You experience the wood rat, which carries entirely different energetic implications than the fire rat.
And before we move on, I want to emphasize that there are so many other localized, beautifully specific systems globally.
The Japanese Godai uses earth, water, fire, wind, and void. The Tibetan Wen tradition focuses on air, water, space, fire, and earth.
But my absolute favorite is the indigenous Maori system in New Zealand. They rely on air, water, fire, and earth, but they replace space or metal with flora.
Which is a striking reflection of their geographical reality. The dense, omnipresent vegetation and forests of New Zealand were so integral to their survival and their environment that flora itself was elevated from a mere object to a fundamental, universal element of reality.
It proves that humanity builds its conceptual universe out of the physical materials that immediately surround us.
And I want to pause here and clarify something for our listeners. When we talk about humorism, Ayurveda, or traditional Chinese medicine, we are examining the historical and philosophical mechanics of these systems.
We are looking objectively at how brilliant ancient thinkers structured reality before the advent of modern instrumentation.
We're exploring them as profound intellectual frameworks, without taking a stance on their efficacy in modern medical practice. They are vital chapters in the history of human cognition.
Absolutely. But the philosophical and mystical reign of these classical elements, a reign that lasted over 2 millennia, was eventually going to face a brutal reckoning.
We arrive at the scientific revolution.
Yes. For 2,000 years, you could win a scientific debate just by being the most persuasive philosopher in the room.
You could argue about Plato's shapes or Aristotle's qualities until you were blue in the face.
But in the 17th century, a new breed of thinkers decided that words and logic weren't enough. They demanded receipts.
They wanted to meticulously weigh and measure actual substances. And that is when the classical elements begin to violently break apart.
The opening salvo in this chemical revolution was fired by an Anglo-Irish natural philosopher named Robert Boyle. In 1661, he published a devastating critique titled The Skeptical Chemist.
And he doesn't just write a dry academic paper. He writes it as a theatrical dialogue between different characters.
You have Themistius, who stubbornly defends the Aristotelian 4 elements. You have Eleutherius, defending the alchemical Paracelsian 3 principles.
And then you have Carneades, who is basically Boyle's intellectual hitman, just tearing both ancient systems to shreds.
Boyle's critique was fundamentally aggressively empirical. He demanded physical proof over philosophical assumption.
In this text, Boyle redefines the word element for the modern age. He states an element must be a primitive and simple or perfectly unmangled body.
It must be a substance that cannot be chemically broken down any further into simpler components.
Boyle reading The Skeptical Chemist to the scientific community is like a harsh, uncompromising restaurant critic marching into a Michelin-star kitchen and demanding to see the raw ingredients.
That's a great way to put it.
For centuries, philosophers had looked at a burning log and said, "Observe, the smoke proves it contains the quality of air, and the ash proves it possesses the principle of earth."
And Boyle slams his fist on the table and says, "Show me. If you claim this wood is made of pure fire and pure water, extract them. Put pure fire in a jar for me. Prove it."
And of course they couldn't.
Because the classical elements were qualitative concepts, they could not survive the unforgiving scrutiny of quantitative analysis.
But science rarely moves in a straight line. Before chemistry could truly move forward, it had to navigate one of the most fascinating intellectual dead ends in history.
The phlogiston theory.
This goes back to the hook we started the show with. In the early 18th century, A German scientist named Georg Ernst Stahl is trying to crack the greatest chemical mystery of the age: combustion.
Why do things burn? Why do they stop burning?
Stahl proposes that all combustible materials, wood, coal, paper, contain a hidden, fire-like substance he calls phlogiston.
The theory argued that when you set a piece of wood on fire, it is violently releasing its trapped phlogiston into the surrounding air.
Once all the phlogiston is depleted, the fire goes out, leaving behind only the dephlogisticated ash.
And if you're just looking at a campfire, the logic is incredibly seductive.
You burn a heavy log, the fire releases the phlogiston, and you are left with a tiny pile of ash that weighs much less than the wood. It makes perfect visual sense.
But the theory catastrophically fractured when chemists began meticulously studying the calcination of metals.
When you heat certain metals, they burn or rust, turning into a powdery substance they called a talc, what we now identify as a metal oxide.
The problem emerged when scientists started using precision balances. They weighed the solid metal, burned it, and then weighed the resulting calcs.
And to their horror, the calx weighed more than the original metal.
If combustion means releasing phlogiston, how on earth could the substance gain mass after losing an ingredient?
The mental gymnastics scientists performed to save the phlogiston theory are astounding. As we mentioned earlier, some serious scholars actually proposed that phlogiston must possess negative weight, or negative gravity.
They argued it was a buoyant fluid that literally lifted the metal, so losing it made the metal heavier.
It shows how desperately human beings will cling to a paradigm they are comfortable with, even when the math is screaming that they are wrong.
The man who finally listened to the math destroyed the phlogiston theory and laid the irrevocable foundation for modern chemistry was Antoine Laurent Lavoisier.
Lavoisier is one of the most brilliant and deeply tragic figures in the history of science. He was a wealthy French aristocrat who originally went to school to become a lawyer to please his family, but his absolute obsession was science.
And he did not work alone. His wife, Marie-Anne Pierret-Pauls, was the unsung co-pilot of the chemical revolution.
Her contributions cannot be overstated. Marie-Anne learned English specifically to translate the latest British scientific memoirs for Lavoisier, as he didn't speak it.
She was highly trained in drawing and engraving, and she produced the incredibly detailed, precise sketches of Lavoisier's complex laboratory apparatuses.
Sketches that allowed his experiments to be replicated and believed across all of Europe. She also managed his laboratory notebooks.
They were an absolute powerhouse team, and the pivotal moment for them comes in 1774.
An eminent English natural philosopher named Joseph Priestley travels to Paris and has dinner with the Lavoisier.
Priestley tells him about an amazing experiment he just did. He took mercury calx, put it in a sealed glass vessel, and focused intense sunlight on it using a massive magnifying glass.
A gas was released. And when Priestley put a lit candle into this gas, the flame burned with blinding intensity.
But Priestley was a staunch defender of the phlogiston theory. He couldn't see past the paradigm.
He theorized that he had discovered a gas that was completely devoid of phlogiston. Because it was empty, it was ravenously hungry to absorb phlogiston from the burning candle, which is why the candle burned so fiercely.
He named it dephlogisticated air.
Lavoisier hears this, goes back to his incredibly expensive, custom-built laboratory, and realizes Priestley is looking at the data completely upside down.
Phlogiston is a myth. Lavoisier realizes that combustion isn't about releasing a magical fire fluid. Combustion is a chemical combination.
Things burn because they are violently bonding with the specific, highly reactive component of the atmospheric air.
Lavoisier names this specific gas oxygen, derived from Greek, meaning acid generator, because he incorrectly believed oxygen was required to make all acids.
But his combustion theory was flawless. He proves that when a metal burns and turns into a calx, it isn't losing phlogiston, it is pulling oxygen out of the air and bonding with it.
The metal gains weight because it is literally adding the mass of the oxygen gas to its own structure.
It was a total triumph of quantitative measurement. But to truly sever the head of the classical elements, Lavoisier had to conquer the most revered ancient element of all: water.
Water had been the undisputed champion of the elemental world since Thales stood on the shores of Miletus in 600 BC. Breaking water meant breaking the ancient world.
The breakthrough starts with another Englishman, the brilliant and notoriously eccentric Henry Cavendish. Cavendish isolates a highly combustible gas that he calls inflammable air, which we now know as hydrogen.
Cavendish builds a specialized apparatus. He mixes his inflammable air with common air inside a glass globe and uses a Leyden jar to run an electrical spark through it.
There's a pop. And Cavendish notices a thin film of dew condensing on the inside of the glass.
Cavendish analyzed the dew and realized it was pure water. But, like Priestley, Cavendish was chained to the old ideas.
He tried to explain the appearance of the water using convoluted phlogiston mechanics.
Lavoisier takes Cavendish's raw data, strips away the phlogiston nonsense, and sees the terrifying, beautiful truth.
In 1783, Lavoisier and his team set up a spectacular public experiment. Using specialized gasometers, he feeds precise amounts of hydrogen and oxygen gas into a glass globe and sparks them.
He successfully synthesizes water.
And then he takes a specialized iron tube, heats it red hot, and passes steam through it, successfully decomposing the water back into hydrogen and oxygen gases.
He proves, irreversibly and quantifiably, that water is not a fundamental element. It is a compound. It is a chemical marriage of two simpler gases.
I want to pause here because this is such a vital lesson about how science operates. Let's look back at an earlier experiment by the Flemish chemist Jan Baptist van Helmont in the 1600s.
He wanted to prove where the mass of a growing plant comes from.
So he takes a large pot, puts exactly 200 pounds of dried soil into it, and plants a 5-pound willow sapling.
For 5 straight years, he adds absolutely nothing to the pot except pure water. He covers the pot so no extra dust can fall in.
After 5 years, he carefully uproots the tree and weighs it. The willow tree now weighs 169 pounds. It gained 164 pounds of mass.
Then he dries out the soil and weighs it again. The soil had lost only about 2 ounces.
To Van Helmont, the conclusion is undeniable. 164 pounds of solid wood, bark, and leaves had materialized seemingly out of nowhere.
Since the only thing he added was water, he concluded that the tree's mass was synthesized entirely out of water. Therefore, water must be the ultimate primary element.
It was a flawlessly executed empirical experiment. The measurements were accurate.
But his conclusion was entirely wrong because he didn't know about the invisible carbon dioxide in the air that the tree was actually breathing in to build its mass.
It is a sobering reminder that perfect empirical data, if viewed through a flawed theoretical framework, can still profoundly mislead us.
Lavoisier finally provided the correct framework.
In 1789, Lavoisier publishes the Traité élémentaire de chimie, the elementary treatise on chemistry. It is essentially the first modern chemistry textbook.
In it, he firmly establishes the law of conservation of mass, stating that in any chemical reaction, matter is neither created nor destroyed, only rearranged.
And most importantly, he publishes the very first modern list of chemical elements: oxygen, nitrogen, hydrogen, phosphorus, zinc, sulfur.
The classical elements, earth, water, air, and fire, were officially dead as physical substances.
Yet Lavoisier's own story ends in senseless tragedy. To fund his incredibly expensive laboratory equipment, Lavoisier had purchased a share in the Femme Générale, a deeply unpopular private tax collection agency that worked for the French monarchy.
He was literally a tax collector.
And he published his groundbreaking treatise in 1789, the exact same year the French Revolution erupted.
During the radical reign of terror, his association with the aristocratic tax collectors made him a prime target for the revolutionaries.
Despite appeals from fellow scientists highlighting his monumental contributions to the nation, the Revolutionary Tribunal was unmoved. The judge infamously declared, "The Republic has no need of scientists."
In May 1794, Antoine Lavoisier was tried, convicted of conspiracy against the people, and sent to the guillotine. He was 50 years old.
He was an incalculable loss. The great mathematician, Joseph Louis Lagrange, heard about the execution and remarked the very next day, he said, "It took them only an instant to cut off that head, and 100 years may not produce another like it."
It genuinely gives me chills.
This man figured out how to weigh the universe, he rewrote our understanding of physical reality, and he was murdered over taxes.
With Lavoisier's revolution complete, the 19th century witnessed an absolute explosion in the discovery of new chemical elements. Chemists were isolating new metals and gases at a frantic pace.
The challenge rapidly shifted from identifying what an element was to figuring out how to organize them.
Right, because suddenly you don't have 4 neat, poetic elements. You have dozens and dozens of them, and it looks like chaos.
Scientists are desperately trying to find the hidden pattern. You have Johann Dobereiner noticing that certain elements form triads with similar properties.
John Newlands proposes the law of octaves, noticing properties repeat every 8th element, much like musical scales.
But the ultimate breakthrough arrives in 1869 with the towering Russian chemist Dmitry Mendeleev.
Mendeleev organizes the 63 elements known at the time by their atomic weights and their valency, their chemical bonding properties. He structures them into the first functional periodic table.
And the true genius of Mendeleev wasn't just that he organized the cards he held in his hand, it was his confidence in the blank spaces.
He looked at his grid and said, there's a gap right here. Based on the mathematics of this table, an element must exist with this exact weight, this specific melting point, and these exact properties. We just haven't dug it out of the ground yet.
He called them Eka aluminum, Eka boron. And years later, chemists found gallium and scandium, and they matched his predictions perfectly.
The periodic table represented the final, unassailable victory of quantitative atomic science over the qualitative, philosophical, classical elements.
But you can't keep a 2,000-year-old idea down forever. The classical elements refuse to stay buried in the ash heap of history.
Because even as hard chemistry abandoned them, modern physics and modern psychology looked back and realized that the ancient Greeks were actually onto something deeply profound.
If we look closely at the modern scientific understanding of the fundamental states of matter, we find an undeniable, almost perfect parallel to the ancient elemental system.
It lines up beautifully. Think about the solid state of matter, where atoms are locked together tightly in a rigid, stable matrix. That is the exact macroscopic behavior of Earth.
Think about the liquid state, fluid, adaptive, taking the shape of its container. That is water.
Think about the gas state, expansive, highly mobile, filling the void. That is air.
And what about fire? In modern physics, fire corresponds to plasma, the superheated, ionized state of matter where electrons are ripped from their nuclei.
The state of matter that makes up lightning and the stars.
The ancients obviously didn't have electron microscopes to understand atomic substructures, but their macroscopic observations of how matter behaves under varying energy levels were remarkably accurate.
They successfully categorized the 4 fundamental ways the physical universe operates.
But the true, profound rebirth of the classical elements didn't occur in a particle accelerator. It happened in the quiet consulting room of the Swiss psychiatrist Carl Jung.
Jung spent years deeply studying medieval alchemical texts, and he realized something vital.
He recognized that for centuries, when alchemists were locked in their dark laboratories, staring into their crucibles, watching lead melt and chemical colors shift, they weren't just doing primitive, bad chemistry.
Because they lacked a rigorous objective framework, because they didn't have Lavoisier's chemistry to explain what was happening in the flask, their minds unconsciously filled in the blanks.
Jung argued that they were projecting their own unconscious psychological processes onto the transforming matter.
So what does this all mean? Jung proposes that for over 2,000 years, humanity was looking out at the physical world, arguing about fire and water, thinking they were doing physics.
When in reality, they were looking into a psychological mirror. They were mapping the architecture of their own minds.
This raises a fascinating question. If the 4 elements were actually psychological projections, what specific aspects of the human mind do they represent?
Jung took the classical elements and mapped them directly onto what he called the 4 fundamental cognitive functions of human consciousness.
Earth became the sensing function. This is our psychological connection to physical reality, how we process concrete details, facts, and our immediate environment.
Water mapped to the feeling function. This isn't just emotion, it's how we evaluate the world subjectively, our internal value systems, and our capacity for empathy.
Air was mapped to the thinking function. This represents the rational intellect, logical deduction, and the analytical processing of abstract concepts.
And finally, fire became the intuition function. This is our capacity for direct, unconscious perception, those sudden flashes of insight, and the ability to see future possibilities that aren't physically present.
And just as Aristotle had his mystical 5th element, the aether that governed the heavens, Jung posited a central unifying point around which these 4 cognitive functions orbit.
He called it the archetype of the self. It represents the ultimate quintessence of human individuation, the perfect integration of the entire psyche.
If you think Jung's mapping is just an obscure historical psychoanalytic theory, you are interacting with its legacy more than you realize.
Jung's 4 elemental functions are the direct theoretical foundation of the Myers-Briggs type indicator.
Yes, that 16 personality test that millions of people take every year for corporate team-building exercises or post in their dating app profiles.
It is entirely built on the bones of earth, water, air, and fire. The framework simply put on a modern suit and changed its vocabulary.
It proves the staggering, enduring utility of this ancient system. The classical elements may have ultimately failed as a literal map of the chemical universe, but they succeeded brilliantly as a map of human consciousness.
What an absolute epic of a journey. Let's recap how far we've come. We started in ancient Babylon with the god Marduk splitting the primordial sea with the winds.
We watched Empedocles shove a bronze bucket underwater to prove the void wasn't empty.
We saw Plato turn the fabric of reality into a set of geometric role-playing dice, and Aristotle build a thermodynamic matrix that controlled medical bleeding for 1,000 years.
We explored the dynamic, self-balancing rock-paper-scissors cycle of the Chinese wuxing.
We witnessed Robert Boyle demand the receipts and the tragic revolutionary genius of Antoine Lavoisier, who finally proved water was a compound, only to lose his life to the guillotine.
And we ended up realizing that as these four elements were pushed out of the periodic table, they retreated right back into the human mind where they started.
It highlights a humbling and fundamental truth about the pursuit of human knowledge. Even when our most cherished scientific paradigms are eventually proven factually incorrect by new technology, the structural archetypes behind them often contain deep, resonant truths about how we interact with the world and how we understand ourselves.
Which leaves me with a final thought I want you, the listener, to really mull over today. If the ancient Greeks and the medieval alchemists unconsciously projected the structure of their own minds onto the physical universe via the four elements, what are we projecting today?
Think about our current cutting-edge scientific obsessions. We constantly hear tech billionaires and theoretical physicists proposing that the universe is a giant computer simulation.
Or cosmologists suggesting that the microscopic structure of the cosmos looks exactly like a vast neural network.
Are we actually finally discovering the true objective nature of reality? Or is this just the modern 21st century version of the classical elements?
Are we simply projecting the architecture of our own brains and the silicon computers we just invented back out onto the stars?
That is a deeply unsettling and fascinating question to carry forward. Thank you so much for joining us on this deep dive. Keep questioning your paradigms, keep exploring the universe around you, and we'll see you next time.